All right, in this video, I'm going to step you through what a binary search tree is. And actually, this is going to be the first part of a multi stage series of videos looking at binary search trees and how they can be used to compress text and images, which is a kind of cool feature. If you looked at data structures, binary search tree is kind of interesting. Trees in general are interesting in their kind of usually the first nonlinear uh, data structure you examine as you're learning data structures. Anyway, so let's learn about them and how they work. And so right here you are seeing an example of a what could be a binary search tree. Um, as you can tell by looking at this, it's composed of these are nodes, and they generally are going to hold integer values. And the top node is, in this example, is 12, and that is referred to as the root node. Everything kind of builds from that. If a value is less than the root, then we examine to the left of it. If it is greater than, then we go ahead and look to the right of it, and that's where that value is placed. We keep doing the same thing. If the value is less, then we move to the right. If it's greater, we move I'm sorry, if it's less, we move to the left. If greater, we move to the right until we get a spot that is null, and that's where we insert our value. Here's kind of an example of what that can look like if we needed to add a node that had a value of 10. This is how we would kind of move through the tree. We'd examine it, compare it to 12. It gets less than it, so it goes over here. Then we compare it to 6. It's greater than it, so then it goes to the right. And so you would keep doing that until you get to a point where there is no value, and that's where you would place that node. So not really anything too complicated. And kind of as I mentioned, trees are really just made up of a bunch of nodes. This is what your node class would look like programmatically. Not a whole lot, pretty simple, just 3 fields to keep track of your data, which is that integer, and then a pointer to a left and a right child, which are just nodes, more nodes in the tree. So here's an example of like you have a value of 50 and you have a left and a right node that you would point to. And kind of as this states here, the root is the only one that is not a child. All the other ones have a parent and thus are a child of another node. And then when you get to the end of the line here, that's a leaf. When there are no more children for a node, then as a leaf. That's an endpoint. And so that's what that's referred to. Just some terminology. So yeah, that all seems simple enough, but what does the code look like? Let me just quickly show you what an insert function, which is probably the most useful function, is to be able to place your nodes in the tree. So I'll show you some starter code, but basically when you call this function, you're going to send it through the root first, and then the data that you want to be a part of that node, right? And so if this was the root, say from this node coming in, it would be 12. You would already have declared the root. So I'm sorry, I'll go back and say, let's say it was 10, right? You come in and the node is not null because we know we're sending the root, which was 12, right? And so we're going to go to the else part, and we're going to compare our value of 10 to the root's value of 12. And yes, it is less than it. So you would make this call here, which basically is a recursive call back here, and we're sending in the left node. And that data of 10 is still going back in. So the left node in our example was 6, right? And so that's going to come back in here. 6 is not null. So we'd come back in here. 10 is not less than it. So we'd go over here and we'd send the right node over. Now in this instance, the right node was null before 10 was added, right? And so you'd come back in and this would be true, and we would add our new value of 10. create that new node. And that's created. And that node of 6 up here actually now is pointing. That's what the whole point of this is. That is pointing to this new node of 10 that we created. So that kind of build your tree. That's how it works. However, it is important to kind of talk about that. This doesn't work unless your tree will not build correctly, I guess is what I'm trying to say, unless the data is inserted in the correct order. Okay, and so here's how you do that. It's not that complicated either, especially if you've ever come across code for binary search. That's very similar to the algorithm you use for inserting your values. So let's say you had this data set that you wanted to make a binary tree out of. That's the example from above uses these values. Well, you would have to sort it first. That's real important. So you could just literally use Java sort functions, or array.sort. And then still after that, then you need to use the following algorithm. Here's what it looks like. This, if you've ever looked at a binary search code, this should look very similar to that. So basically the whole idea is you get the midpoint of your data, which in this instance would be 12. That's dead center, right? And if there was no root assigned, that becomes the root. So the first time through, that's going to be the root. For every other time through, what you're going to do is you're going to send back the lower half, or all the values to the left of the root, right? So you would send all this back, and you would simply just get the midpoint again, right? And then you do the same for everything to the right of the root as well. You get the midpoint, insert that midpoint, send everything back, and you just keep on doing that. And that is the proper order for how you insert. I'll share all this code with you, by the way. I'm just showing you a couple other functions. Find function is handy just to determine whether a particular node with a value is in our tree, and you always send it the root as the starting point. And then all this is recursion again. You keep going back in and looking left or right based on whether the value that you're looking for is less than or greater than the value at the current node that you are examining, right? So last thing I'm going to show you is a show values function. This isn't necessary, but it is helpful for just validating that your tree that you, after you inserted things, it's good to look at this to make sure, was my tree created correctly? Are they in the order that I was hoping they would be? And this will print out your tree accordingly, again, using recursion. It'll show you the parent and then each child. So super helpful. So that's it. That's all I'm going to talk about with binary search trees. I'll share this code, as I said, so you can play around with it if you want. The next video, I'm going to kind of show you how to get started doing compression with this. We're going to do a little compression with some text, and how you can encode it and then decode it. So basically compressing it and then uncompressing it so that you can actually get back so the whole idea is you compress it and then send it somewhere, and then you can decompress it to view that data again in its original form. All right, thank you. Let me know if you have any questions.